Hello, everybody. This is going to be our third question for our review for our MRS21 Fall 2020 midterm. So this is the last one, and so this one is a piecewise function. Smart Real Electric Company will have a monthly charge of $0.032, or really 3.2 cents, for every kilowatt hour used by a household up to 3,000 kilowatt hours. As a way to encourage saving electricity, its price increases to $0.045 for every kilowatt hour used after 3,000, but up to 6,000 kilowatt hours. And the price increases to $0.095 for every kilowatt hours over 6,000 used by the household. And so the cost of electricity is going to increase if you're going in stages, if you're going to use more of it. And so trying to help people, just encourage people to maybe save electricity, well, charge more. So now we'll create a piecewise function, E of x, the monthly cost electric bill, where x is the number of monthly kilowatt hours used by a household. So a couple of things you want to do. First thing you want to do is establish your domains, your domain intervals in this case. And so we see in our first domain interval that we see that we have a charge of 0.032 for every kilowatt hour used up to 3,000 kilowatt hours. And so for E of x, and there'll be 3 tiers for this one, we're dealing with all values x greater than 0, but less than or equal to 3,000. Okay, and so to find this null, we're just going to basically say, well, how do you do that? Well, it's up to 3,000 kilowatt hours. So that's your first tier. And the price of how much it's going to cost is going to be taking the cost of 0.032 and just multiplying by x. And that one seems pretty straightforward, so not a big deal. All right, so yeah, take the number of kilowatt hours and multiply by that by the cost per kilowatt hour, and then so that will be the monthly charge. However, the next tier is for values after 3,000 but up to 6,000. Okay, and so that means for all values of x greater than 3,000 but less than or equal to 6,000. So that's the interval here. Right, and before we find the function itself, let's establish the last interval. In this case, it's going to be x is greater than 6,000. Now, first off, why is this the second one between 3,000 and 6,000? It says, well, the price is 0.045 for every kilowatt hour used after 3,000. So this new charge kicks in only after you hit usage of more than 3,000, but up to 6,000 because it's the next tier after that. And so we see in this case, okay, well then that's what we have. It's up between 3,000 and 6,000. So now the last tier in this case is for 0.095 for every kilowatt hour after over 6,000. So we'll see in this case that our domain for this will be x is greater than 6,000. And again, it's a new charge. So we're thinking, well, for the second tier, would it just be 0.045 times x? The problem is, since x is the total use, it's not exactly the same thing. Okay. We definitely see in this case that, let me move this down a little bit for a little room. Okay. Maybe I'll move this down as well too. We'll see in this case that we're definitely going to multiply for the second tier 0.045, but only for values of x between 3,000 and 6,000. Now to get that, we definitely have to say to yourself, okay, 0.045, definitely multiplying something like this. But if we want values between 2,000 and 6,000, well, it just can't be x, since we know x has to be greater than 3,000. all right? And we could only count for our values for, we're going to charge that 0.05 for only values greater than 3,000, then we will be multiplying 0.05 for x minus 3,000, okay? X minus 3,000. And so why is this? So again, like say for example, I'm charging this like 3,100 kilowatt hours. For 3,100 kilowatt hours, it does not mean all those kilowatt hours are charged at the new rate. Only the amount above 3,000. And so that would be in this case, well, 100, because 3,100 is going to be only 100 above 3,000. So this is why we need that x minus 3,000. The problem is we have to keep in mind that before there was there was a amount that was at the lower rate. So we want to know that, because we don't include that in our amounts, we're not going to get the accurate value. To get that value, what we're going to do is we're going to take 0.32 and multiply by that value of 3,000. When we do this, we get the value of 96. So if a household uses exactly 3,000 kilowatt hours, their monthly bill will be $96. If it's going to be now based upon what we have here, that would mean in this case that amount is just amount above the 2,000, above the use of 2,000. So to include everything, we're going to add $96. And now we simplify. Distribute here, we have 0.045x, and 0.045 times 3,000 is equal to 135, so minus 135 plus 96 means in this case our next function value will be 0.045x, and 135 minus 96 is going to be 39 minus 39. So that's going to be our second function here, 0.045x minus 39. Okay. Now, we have a third tier to get to. Our third tier would mean we have, in this case, 0.095. So again, 0.095, and that's only charge the values above 6,000 used to 6,000 kilowatt hours. So that means we're only going to be charging x minus 6,000. And so that would be that portion of the bill. If you have usage of over 6,000 kilowatt hours, then only that portion above 6,000 we charged 0.095. And so that in this case again, if you have 7 kilowatt hour use of 7,000, well, we're only charge 0.095 for the 1,000 above. That's why we get the x minus 6,000. But then again, we have to incorporate the prices from before, and so we know in this case that we had 0.45. So you went to 0.32 times 2,000 equals 96. Now the 0.032. Sorry about that, ladies and gentlemen. It should be 0.022 and 0.045. You're wondering why the number worked out that way. So 0.05 now times 3,000, and you guys saying, why is it 3,000? Because the interval is only between 3,000 6,000 is a difference of 3,000. And so that being the case, we multiply this much, that's going to be a value of 135. So what comes down to is that if you were to have to use exactly 6,000 kilowatt hours, you would pay first 96 for the first 3,000 and then 135 for the next 3,000. All right. And so in our equation for the third function, we're now going to add the 96 and the 135 here. And then again, distribute. So distribute here. So we get 0.095x minus 0.095 times 6,000 is going to be 570. We're adding 96 and 135. And if you add it all together, you get 0.095x and minus 339. Okay. So in this case, it's again pretty tricky, but you follow the same concept throughout. The first one is just going to be multiplying. First one's going to multiply, in this case, the x times the first amount of 0.032. All right. Then what you want to do is multiply this 0.032 by this maximum number here, and you're gonna basically subtract that from the second amount, 0.045, but then of course x minus this interval, this value here of 3,000. Okay, and then combine, and then for the third interval, 0.095 times x minus this number here, all right, well, this number here, 6,000, that max value, bring it to the next tier. But then you're going to add back, in this case, the two max values of 0.032 times 3,000, which is 96, plus 0.045 times 2,000, 135. And so we can get the true value of the bill, all right? So ladies and gentlemen, let me just make this full page for now. It's kind of, if you want to kind of do this all in one video, but not going to happen in this case, because so in this case, ladies and gentlemen, this is the function, all right, and it's going to take a bit of time to work out, but notice how notice the work you're going to be putting in for each one of these things. Okay, all right, so this is where I end the video, and I'm going to pick up in part 2 of question 3 in our next video, because I want to make sure I have time to work on this. Okay, get to watch this one. All right, hope this helps, and again, if you found it helpful, please give it a like. Right, I'll see you in the next video. Right, take care.